Hey guys, sorry I can't be there this week, but I'm just going to be posting videos every morning and just watch them on Delta Math. Um, if you're not able to watch them on Delta Math on any given day, you can watch them on YouTube directly. You just have to search for my channel, Skip Baxter, but you have to make sure that if that's the way you do it, that you email me so you get credit for attendance for the day. Um, Other than that, if you have any questions at any time, please don't hesitate to get in touch with me by email, and I can respond right away or set up a Google Meet with you if you need more help or whatever. Okay, but just I wouldn't let it wait um, until I get back. All right. So if you have questions, make sure you ask them, and we can get it cleared up. Okay. So today we're just going to talk more review with trig stuff. So today we're going to talk about reference angles and quadrants. Okay, so the other day we talked about the unit circle and the fact that any point that's on the unit circle has coordinates cosine theta, sine theta, right? So this point right here would have coordinates cosine theta, sine theta, where theta is this angle right here. All right. But another thing that's true about the unit circle, if you just think about it rationally here, logically, is if you have a point on the unit circle, for example, this point right here, whose coordinates are x, y, whatever x and y might be, right? Well, there's a corresponding point right here on the unit circle whose coordinates are negative x, y, right? They have the same coordinates except for the x value is negative. And there's a point right here that has coordinates x negative y, right? It just goes positive and then negative. And then there's a corresponding point here that has the same coordinates, but its coordinates would be negative x, negative y, right? So for any point on the unit circle, there's three other points on the unit circle that have the same coordinates except possibly negative, right? So if you relate that to the fact that any point on the unit circle has coordinates cosine theta, sine theta, what that tells you is that any 2 points or 3 points or 4 points that have the same reference angle have the same trig values, right? So by reference angle, remember what that means. A reference angle is the positive acute angle between the terminal side of an angle and the x-axis. So in this picture that I have up here of the unit circle, the reference angles would be like this angle right here, or this angle right here, or this angle over here, or this angle over here. You can see that in this picture, those angles are all the same, right? Those are the 4 reference angles of those points, okay? So a reference angle is a positive acute angle between the terminal side of an angle and the x-axis. And furthermore, fact, any angles with the same reference angle have the same trig values. Except possibly negative. Okay, so it's useful to be able to calculate reference angles. Now, to actually calculate a reference angle, it sort of depends where the angle is located, right? Like, for example, if I had a piece of paper, if I had an angle that's already in the first quadrant, right? It already is an acute angle, right? So if I have an angle that when I draw it, it just looks like this, right? Well, in that case, the angle itself is the reference angle. The angle itself is the reference angle, right? But if you have an angle, suppose you have an angle theta that when you draw it, it ends up over here in the second quadrant, right? Well, now to calculate the reference angle, it's this angle right here, right? Well, that angle isn't the angle itself. This is theta here. This angle ends up being 180 minus theta, right? That's what this is. The reference angle in this case is 180 minus theta. Okay. If you have a third quadrant angle, like say you draw the angle and it ends up right here. Okay, if this is the angle theta, now to find the reference angle, which happens to be this angle right here, that reference angle is, it would be theta minus 180. Right? If I take the whole angle and I subtract like this part of it from here over, right? That gives me what's the reference angle is. And if it's a fourth quadrant angle, something between 270 and 360, right? That's theta. In this case, the reference angle is right here, which is 360 minus that angle. So this is going to be 360 minus theta. Okay, so it depends on where the reference angle ends up, how to calculate it. All right, it's a little confusing to try and like memorize this. Like, okay, if it's there, then that's the reference angle. If it's here, then that's the reference angle. If it's there, then it's theta minus 180. If it's here, it's 360 minus theta. That's confusing. So I think an easier way to just to know how to calculate the reference angle is to just draw it every time and just figure it out. I really think that that's easier than just memorizing random facts. Okay, so that's the first thing you have to be able to do is just find a reference angle. So for example, if the angle theta happens to be like 310 degrees, okay, you draw a little picture. I know 310 is more than 270, but it's less than 360. So it's going to end up over here somewhere, right? So if this angle is 310, that's theta, then I just want to know like how many more degrees do I have to go before I get to 360? It would be 50 degrees. That's how many degrees are like left over. That's the reference angle. All right, so that's the first thing you need to be able to do is just calculate reference angles easily. If it was something like, what if it was a negative angle? Like suppose it was theta equals negative 200 degrees. Same process. I know this time though I'm going to rotate clockwise, right? So negative 200 is more than 180, but less than 270. So if this is the angle you're trying to find, you just want to know, well, how much more than 180 did you go? You went 20 degrees, and that's the reference angle, 20 degrees. Okay? So it's pretty easy. You should be good at this from last year, but let me just do one more example. Suppose it was something like theta equals, what if it was more than 360? Like what if it was 400 degrees? Same thing. I know 360 is a complete rotation. So 400 would be 60 degrees more than that. And if that's the angle I'm trying to find right there, that's 60. That's how many more degrees did you go. Now, the common mistake people make when they're calculating reference angle is sometimes they'll calculate the angle between the terminal side and the y-axis, like that angle instead. But that's not it. It's always between the terminal side and the x-axis. So you always go straight to the x-axis. Okay? That's the first type of problem. The second type of problem that they might give you is they'll give you an angle that's larger than 360. Okay? Like for example, they'll give you something like theta equals 512 degrees or something like that. And they'll ask you a few questions about it. They'll say, first of all, find a coterminal angle that's between 0 and 360. So remember, a coterminal angle is just an angle that has the same terminal side when drawn in standard position. Okay, so a coterminal angle has the same terminal side. In standard position. So standard position is just starting from the positive x-axis and rotating counterclockwise. So in standard position. Okay, so in this case, if we have 512, you can always get a coterminal angle just by adding or subtracting 360, right? You just add or subtract 360 degrees or 2 pi, right? Just add or subtract 360, right? So like, think about it. Like if I have, for example, a 60-degree angle like this, right? If this is 60 and I want a coterminal angle, all I want to do is just rotate 360 plus 60. Or I could go 2 complete rotations plus 60. Or I can go 3 complete rotations plus 60, or so on. And all those angles are going to end up being in the same spot when you end up. Okay, they have the same terminal side. So to get a coterminal angle for 512, all I have to do is subtract 360 to get it down to something between 0 and 360. So I got my calculator here. If I take 512 minus 360, I get 152. So that would be the coterminal angle. That's between 0 and 360. Okay, there's lots of coterminal angles. That's the one that they're looking for, between 0 and 360. Then they'll ask you other questions about this same angle. They'll ask you, for example, what's the reference angle? Okay, well, the reference angle, I know that 152 degrees is more than 90, but it's less than 180, right? So it's going to be like here somewhere. So the reference angle would be this angle. How many degrees would it take to go more than 152 to get to that x-axis? So in this case, it would be 28 degrees. That would be the reference angle they're looking for. And the final question they might ask you is, what quadrant does this angle lie in if you graph it? And so remember, the quadrants are numbered 1, 2, 3, and 4. So in this case, this would be a second quadrant angle. Okay? So those are the questions that you'll be expected to answer about these large angles. So what if they gave you an even larger angle? So for example, or maybe negative. What if they said something like theta equals negative 1205 degrees? Okay, same 3 questions. What's the coterminal angle between 0 and 360? What's the reference angle? And what quadrant does it lie in? Same 3 questions, okay? So to get, in this case, to get the angle, the coterminal angle between 0 and 360, you would need to add 360. So if I use my calculator and I start with negative 1205, and I just keep adding 360. So I'm going to add 360, get an answer. Okay, I'm still not between 0 and 360. I'm at negative 845. Add 360 again. I'm still not there. Add 360 again. Still not there. Add 360 again. Now I'm there. So the answer they're looking for here would be 235. That's the coterminal angle that's between 0 and 360. Okay? The next thing they'll ask you to do then is find the reference angle. Okay, so the reference angle for 235, that's more than 180, but less than 270. It's over here somewhere, right? So the reference angle would be right here. So you're going to take the whole angle minus 180, right? So if I take 235 and I subtract 180 from it, I get 55 degrees. That's this angle. That's the reference angle. And finally, it lies in quadrant 3. So that would be all 3 questions answered for this angle. The coterminal angle between 0 and 360, the reference angle, and the quadrant that the angle lies in. Okay? And then the last type of question that you're going to see on your homework is questions where they give you an angle. For example, they might give you something like, suppose they gave you something like 150 degrees. They might say something like, find all four angles between 0 and 360 that have the same reference angle as 150. Okay, so find all three angles between 0 degrees and 360 that have the same reference angle. So all you need to do is figure out what that reference angle is. Okay, so in this case, 150 is between 0, it's more than 90, but it's less than 180. So 150 would be like over here. The reference angle is 30, right? So then all they want to know is, well, what's the angle in the first quadrant where this angle is 30? The answer is 30, right? What's the angle in the second quadrant where this angle is 30? This would be 150. What's the angle in the third quadrant where this angle is 30? That angle would be 180 plus 30, 210. And finally, what's the angle in the fourth quadrant where this angle is 30? And it would be this angle right here, 330. All right, so that's what they're looking for. They're looking for the four angles that all have the same reference angle as 150 degrees. Okay, so just figure out what the reference angle is, and then just do the calculations for each of the four quadrants. All right, that's it for today. Thanks for watching, and I'll put out another video for tomorrow morning. Thanks, guys.